Yo, what's up guys? Welcome back to Chemistry Education Academy. The place where chemistry stops being boring and actually starts making sense. In the last video we talked about the allotropic forms of substances, and honestly that topic was kind of fire. But today, we're diving into something super important and crazy interesting. Solutions. Colloids. Suspensions. Saturated and unsaturated solutions. And how temperature totally changes solubility. Trust me, by the end of this video chemistry class is gonna feel way less confusing. So, grab your notebook, maybe a snack, and let's jump right in. What is a solution? A solution is a homogeneous mixture formed when one substance dissolves completely into another substance. In simple words, when two substances mix so perfectly that they look like a single substance, that mixture is called a solution. The word homogeneous means same throughout. That means every part of the solution has the same composition. For example, if you mix salt and water, after some time the salt completely disappears and spreads evenly in the water. You cannot tell which part contains more salt and which contains less. That smooth mixture is called a solution. Components of a solution. Every solution has two main components. Solute. The substance that gets dissolved in another substance is called the solute. Usually present in a smaller amount. Examples: salt in water, sugar in tea, carbon dioxide in soft drinks. Solvent. The substance in which the solute dissolves is called the solvent. Usually present in a larger amount. Examples: water in salt solution, tea in sugar tea, water in soft drinks. Characteristics of a solution. Now let's discuss the important properties of solutions in detail. 1. Homogeneous mixture. A solution has uniform composition throughout. That means every part of the solution is exactly the same. You cannot identify different substances separately. Example: if you drink tea from the top or bottom of the cup, the taste remains the same because sugar is evenly mixed. 2. Particles are extremely small. The particles of a solution are very tiny. They are usually smaller than 1 nanometer in size. Because of their tiny size, they cannot be seen with naked eyes. They cannot even be seen with ordinary microscopes. Example: you cannot see sugar particles after dissolving them in water. 3. Particles do not settle down. The dissolved particles remain evenly distributed in the solution. Even if the solution is left undisturbed for a long time, the particles do not settle at the bottom. Example: salt water remains mixed even after hours, for it cannot be separated by ordinary filtration. Since solute particles are extremely small, they pass through filter paper easily. That's why ordinary filtration cannot separate them. Example: you cannot separate dissolved sugar from tea using filter paper. 5. Transparent in appearance. Most solutions are transparent. Light can pass through them easily. Unlike suspensions, solutions do not scatter light. Example: salt water looks clear and transparent. Types of solutions. Solutions can exist in different forms depending on the states of solute and solvent. 1. Solid in liquid. Example: salt in water, sugar in tea. 2. Liquid in liquid. Example: alcohol mixed with water. 3. Gas in liquid. Example: carbon dioxide in soft drinks. 4. Gas in gas. Example: air. Importance of solutions in daily life. Solutions are everywhere around us. In food, tea, coffee, soft drinks, lemon juice. In medicine, syrups, saline water, medical injections. In industry, paints, cleaning liquids, chemical manufacturing. In nature. Sea water. Air. Colloidal solution and Tyndall effect. What is a colloidal solution? A colloidal solution, or simply a colloid, is a type of mixture in which very tiny particles of one substance are evenly spread throughout another substance. These particles are bigger than solution particles, smaller than suspension particles. So basically, colloids are right in the middle between a true solution and a suspension. In a colloid, the particles do not completely dissolve, but they stay evenly distributed throughout the mixture. Understanding colloids in simple words. Imagine you pour milk into a glass. At first glance, milk looks completely smooth and uniform, right? But scientifically, milk actually contains tiny fat particles spread throughout water. These particles are so small that you cannot see them with naked eyes. They do not settle down. They stay suspended in the mixture. That's why milk is called a colloidal solution. Examples of colloidal solutions. Now let's talk about common examples we see every day. Milk. Milk is one of the most famous examples of a colloid. It contains tiny fat droplets. Water. The fat particles stay evenly spread throughout the liquid. That's why milk looks smooth and creamy. Fog. Fog is actually a colloid too. Tiny water droplets are dispersed in air. When light passes through fog, it becomes visible because the fog particles scatter the light. Jelly. Jelly contains tiny particles trapped inside water, giving it a semi-solid structure. That makes jelly a colloidal system. Butter. Butter is another colloid where water droplets are dispersed inside fat. Blood. Blood is also considered a colloidal mixture because it contains proteins, cells, other particles. These remain suspended in plasma. Characteristics of colloids. Now let's study the important properties of colloidal solutions in detail. One appears homogeneous but actually heterogeneous. This is one of the coolest things about colloids. From outside, colloids look completely uniform like a true solution. But scientifically, they are actually heterogeneous because different substances are present separately. Example. Milk looks uniform, but it contains tiny fat particles floating in water. Two particles are not visible to naked eye. Colloidal particles are extremely tiny. You cannot see them directly with your eyes, however they are larger than solution particles. Some colloidal particles can even be observed under special microscopes. Three particles do not settle down. One major property of colloids is stability. The particles remain suspended throughout the mixture. Even if you leave the colloid standing for a long time, the particles usually do not settle at the bottom. Example. Milk stays mixed even after hours. For shows Tyndall effect. This is the most important property of colloids. Colloids scatter light passing through them. This scattering of light is called the Tyndall effect. Because colloidal particles are bigger than solution particles, they can block and scatter light rays. What is the Tyndall effect? The Tyndall effect is the scattering of light by colloidal particles. When a beam of light passes through a colloid, the path of light becomes visible. This happens because colloidal particles reflect and scatter the light in different directions. Examples of Tyndall effect. Light passing through milk. If you shine a flashlight through milk, you can clearly see the beam of light. That visible path is due to the Tyndall effect. Fog and car headlights. At night, car headlights become visible in fog. Why? Because fog particles scatter the light. That's another example of the Tyndall effect. Sunlight in a dusty room. Ever notice sunlight entering through a window and becoming visible in a dusty room? That's also because tiny particles scatter the light. Why true solutions do not show Tyndall effect? In true solutions, particles are extremely tiny. They cannot scatter light. So the light passes straight through without becoming visible. Example: salt water does not show the Tyndall effect. Importance of colloids in daily life. Colloids are super important in science and everyday life. In food, milk, butter, ice cream, jelly. In nature, fog, clouds. In medicine, blood plasma, medicines. In industry, paints, cosmetics, ink. Suspension. A suspension is a heterogeneous mixture in which insoluble particles are spread throughout another substance. The particles in a suspension are large enough to be seen with naked eyes. Unlike true solutions, the particles do not dissolve completely. They remain floating for some time. Eventually they settle down due to gravity. Understanding suspension in simple words. Imagine you mix sand in water. At first, the sand spreads throughout the water. But after a few minutes the sand settles at the bottom. That mixture is called a suspension. Why? Because the particles are too large to stay permanently mixed. Examples of suspensions. Now let's check out some common examples from daily life. Muddy water. One of the best examples of a suspension. Soil particles remain mixed in water temporarily. After some time the mud settles down at the bottom. Chalk powder in water. If chalk powder is mixed with water the particles remain visible, the mixture looks cloudy. Particles settle after some time. That's a suspension. Flour in water. Flour particles remain suspended for a short period but later settle down. Dust in air. Dust particles floating in air also form a suspension. Some liquid medicines. Many medicines have labels saying shake well before use. Why? Because the particles settle down over time, which means the medicine is a suspension. Characteristics of suspensions. Now let's discuss the major properties of suspensions in detail. 1. Heterogeneous mixture. A suspension is not uniform throughout. Different parts of the mixture contain different amounts of particles. That's why suspensions are called heterogeneous mixtures. Example: in muddy water some areas may contain more mud particles than others. 2. Particles are large. The particles in a suspension are much larger than solution particles. Colloidal particles. Because of their large size they can often be seen with naked eyes. Example: you can easily observe sand particles in water. 3. Particles settle down. This is the most important property of suspensions. When left undisturbed particles settle at the bottom due to gravity. This process is called sedimentation. Example: mud settles at the bottom of muddy water after some time. 4. Can be separated by filtration. Since suspension particles are large they cannot pass through filter paper. That means suspensions can easily be separated using filtration. Example: you can separate sand from water using a filter. 5. Suspension is opaque. Suspensions usually look cloudy or opaque. Light cannot pass clearly through them. This happens because the large particles block and scatter light. What happens in sedimentation? When suspension particles settle down at the bottom the process is called sedimentation. The clear liquid above the settled particles is called the supernatant liquid. Example: in muddy water, mud settles at the bottom. Clear water remains on top. Tyndall effect in suspensions. Suspensions can also scatter light because their particles are large. When light passes through, the path of light becomes visible. However, unlike colloids, suspension particles are much larger and often make the mixture look completely cloudy. Importance of suspensions in daily life. Suspensions are used in many areas. In medicine, syrups, antacids, injectable medicines. In construction, cement mixed with water. In nature, muddy river water, dust storms. In food, fruit juices with pulp. Formation of saturated and unsaturated solutions. This topic is all about how substances dissolve, why some solutions can dissolve more solute and why sometimes extra solute just sits at the bottom like. So let's break it all down step by step in a super easy and detailed way. What is solubility? Before understanding saturated and unsaturated solutions, first we need to understand solubility. Solubility is the ability of a solute to dissolve in a solvent. Different substances have different solubilities. For example, sugar dissolves easily in water. Sand does not dissolve in water. Also, temperature affects solubility. Usually when temperature increases, more solid solute dissolves in liquid solvent. Formation of an unsaturated solution. What is an unsaturated solution? An unsaturated solution is a solution that can still dissolve more solute at a given temperature. In simple words, the solvent still has the capacity to dissolve additional solute. How is an unsaturated solution formed? Let's understand step by step. Step 1. Take a glass of water. Step 2. Add a small amount of sugar or salt. Step 3. Stir the mixture. The solute dissolves completely. Step 4. Add a little more solute. It still dissolves. This means the solution has not reached its maximum dissolving capacity. So the solution formed is called an unsaturated solution. Example of unsaturated solution. Imagine adding 1 spoon of sugar into tea. The sugar dissolves completely. Then you add another spoon. It still dissolves. That means the tea can still dissolve more sugar. So the tea is an unsaturated solution. Characteristics of unsaturated solutions. Can dissolve more solute. The main property is that more solute can still dissolve. No undissolved particles. All the solute dissolves completely. Stable and clear. The solution usually appears transparent and uniform. Formation of a saturated solution. What is a saturated solution? A saturated solution is a solution that cannot dissolve any more solute at a given temperature. The solvent has reached its maximum dissolving capacity. How is a saturated solution formed? Now let's understand its formation step by step. Step 1. Take a glass of water. Step 2. Add sugar little by little while stirring continuously. At first, the sugar dissolves completely. Step 3. Keep adding more sugar. Eventually, a point comes where no more sugar dissolves. The extra sugar remains at the bottom. This means the solution has reached its maximum capacity. So this solution is called a saturated solution. Example of saturated solution. Suppose you keep adding sugar into cold water. After some time, the water stops dissolving sugar. Extra sugar settles at the bottom. That's a saturated solution. Characteristics of saturated solutions. Cannot dissolve more solute. The solvent becomes fully loaded with dissolved particles. Extra solute remains undissolved. Any additional solute settles down. Dynamic equilibrium may occur. At saturation, dissolving and crystallization happen at the same rate. Effect of temperature on saturated solutions. Temperature plays a huge role in saturation. Usually, higher temperature increases solubility. That means hot water can dissolve more sugar than cold water. Example. If you prepare a saturated sugar solution in hot water and then cool it, some sugar crystals may appear. Why? Because colder water cannot hold as much dissolved sugar. Supersaturated solution. Sometimes, a hot saturated solution is cooled carefully. As it cools, it temporarily contains more dissolved solute than normally possible. This is called a supersaturated solution. These solutions are unstable. A slight disturbance can cause crystals to form suddenly. Daily life examples. Unsaturated solution. Normal tea with little sugar. Salt water with small amount of salt. Saturated solution. Water with excess sugar at the bottom. Salt solution where extra salt remains undissolved. Effect of temperature on solubility. This topic explains why sugar dissolves faster in hot tea. Why cold drinks contain dissolved gas and why crystals form when solutions cool down. So let's get into it step by step in the easiest way possible. What is solubility? Before talking about temperature, first let's quickly revise solubility. Solubility is the maximum amount of solute that can dissolve in a specific amount of solvent at a given temperature. In simple words, it tells us how much substance can dissolve in another substance. Relationship between temperature and solubility. Temperature has a huge effect on how substances dissolve. But here's the important part. The effect of temperature is different for solids in liquids, gases in liquids. So we'll study both separately. Effect of temperature on solubility of solids in liquids. For most solid substances, when temperature increases, solubility also increases. That means hot liquids can dissolve more solid solute than cold liquids. Why does this happen? When temperature rises, the particles of the solvent gain more kinetic energy. They move faster. The spaces between particles increase. Because of this, solvent particles can break apart and surround more solute particles. As a result, more solute dissolves. Example: sugar in tea. Think about making tea. If you add sugar to cold tea, it dissolves slowly. But if you add sugar to hot tea, it dissolves quickly and in larger amounts. Why? Because higher temperature increases the solubility of sugar. Example: salt in water. Hot water can dissolve more salt compared to cold water. That's why many industrial chemical processes use heat to dissolve substances faster. Formation of crystals on cooling. Now here's something really interesting. Suppose you prepare a hot saturated solution. At high temperature, a large amount of solute dissolves. But when the solution cools, solubility decreases. The extra dissolved solute can no longer stay dissolved and starts forming crystals. Example: if you dissolve a lot of sugar in hot water and then cool it, sugar crystals may appear. This principle is used in crystal formation, purification of chemicals, rock candy production,